This is Structural Analyze and Modeling Portal Section Response Spectrum Analyze GSA tutorial part. For this tutorial, you should be able to learn how to conduct response spectrum analysis in GSA. Before you start watching this tutorial, it's recommended that you should have gone through the section response spectrum analysis individual assignment, section model analysis, and section response spectrum. This tutorial is based on a 2 degrees of freedom system model, and you should be able to construct a 3 degrees of freedom system model later after you watch this video. The first part of this tutorial is the same as in section model analysis GSA tutorial, and you should get the result looks like that, as well as the response spectrum is generated from the output of section response spectrum seismo signal tutorial. Showing here is the period and the pseudo accelerations scaled in the unit of meter per square second. Okay, so first of all, we should create a new file, populate its relevant info, which is control, analyze, and modeling, photo, and subtitle will be response spectrum analyze, and we can leave the rest as the default setting. Okay, then structural type is base, the unit is kilonewton-meter, so we can change, beware of the unit of length small, and we can change the stress to a familiar unit. If you feel you're confused about the Newton per square millimeter, so you can change it to the megapascal or gigapascal. In this case, we will use Newton per square meter, which is also the par, since the info given to us in the section model analysis is use the unit of Newton per square meter. And press OK. Finish. Since we use the first record in the section model analysis individual assignment, so yeah, the info will contains that the mass is 100 ton, which is all equal to 100,000 kilogram. The elastic modulus is 2.80 E plus 10 par, which is Newton per square meter. The cross-section size is B equal to 1.0 meter, and the height is 5.0 meters. So first of all, we define knots, coordinates. There will be 0, here 0, 0, 0, and 0, 0, 5, 0, 0, 10. Okay, so let's go to the graphic view and have a look. Label the number. So we get 1, 2, 3 knots. Then we use the add elements gap tools to link these knots together. And click on here. Label the element number, so we can see we construct 2 elements, which is 1, and there is 2. Then we go to the element, and we also input 2 mass on it. So be aware that we want to put a mass at node 2 and to put a mass at node 3. So we go to the gateway menu, elements, select line 3, use wizard, or right click, use wizard. Say the first one with floor 1, and the type is mass. We want it to place at node 2, the property is 1, which should be defined later. And for the next one, will also be another mass, floor 2, and the type is mass. We want it to at 3. So the property is still the same as 1, because in the model analyze section, we only the two masses, they have the same value. So let's have a look at the graphic view. at point 2 it has a small square, as well as in point 3 it has a small square, represent the mass. Okay, then let's now define the property part. First, we will define the material property. We need a zero density concrete, so it's not one of the materials built in the GSA program, so we need to use define it. So first of all, we select this line, use wizard, and give a name as concrete, zero density. So material type will be concrete. Copy standard material is shortened. So let's check the elastic modulus is 2.8 E plus 10, which is the same as specified to us. And the density is used as 0 because we want zero density material. Then we click finish. So you see it doesn't change the name, so we can alter the name by ourselves. Later, after we define the material property, we can go to the section properties to define the cross section. So select the first line, double click or use wizard to change it. The name we can say the like column. Material use the concrete zero density as we just defined. The cross section size is rectangular, solid, and the unit that will be 1 meter equal to 1000 millimeter by 1000 millimeter. Okay, and press next and have a look at the property. It seems right, so click finish. Then we go to the graphic view and do the visual check, so that right now element 2 and element 3 have the cross section property. So you can have a look at here, because for element 1 and element 2 their property is all set as 1, which is the property of the cross section here, so they will change it automatically. Then we need to define the mass properties. So the mass properties, give the name as mass. The mass, beware of the unit at the upper right corner, that will be turned, so the mass will be 100 as specified in the session model analyze individual assignment. And we can leave the rest as default setting. Okay, after we finish defining the mass property, then we can go to the gateway menu, cases and tasks, analyze task, and to build a new model to conduct the model analyze. So we can right click here or use the 2 here at the top toolbar menu. So the task name can be model analyze, and select the dynamic model. Since we have 2 nodes, so there will be 2. And be aware that when you're constructing the 3 degrees of freedom system, you should change the number to 3. Next, and finish. It can be analyzed now. Oh, there is a problem that I forget, which is to define the constraint. So first of all, we can go to the gateway menu and change constraint here, because we need to restrain all the direction in node 1 because it's at the base, and then we restrain all the directions in 2 and 3, but not x direction, because we want to see how the structure behave in x direction. This is actually a pretty slow process, so all we can do actually is use the nodal selection, select node 2 and node 3, right click, modify selected node, and in custom all, but leave x, don't modify it. Then we can click on the label restraints. So have a look. At the base, which is node 1, is in cast, so it's fixed in all directions. In node 2 and node 3, they restrain the same y, z, x, x, y, y, z, z directions, but not x direction. Okay, so once again, we can go to the analyze task and analyze this task. So yeah, there's no 1 in this time. And then go to the graphic. We select the case 1, we close these 2, and have a look at this mode shape. the frequency. So the period for the mode 1 is 0.2268. For mode 2, that was 0.0865. Then we click on the control settings and go to Modal result, displacement, translation UX, controls based on actual values. Then we can read the mode shape of this one in mode 2 and mode 1. If you are not so sure about the results, you can option here, you can use the select for animation on the left hand toolbar and select these two, and so you see the value of here is 1000 millimeter, here is 618 millimeter. So then we can have a look at mode 2. Here is negative 618 millimeter, and here is 1000 millimeter. It's the same as shown here. Okay, after we have defined everything, we should conduct a response spectrum analysis. So from the gateway menu, let's close this all and go to dynamic response, response spectrum. We define a new one, double click it or use the wizard, or right click, use wizard. Select user define and select constant. Set the damping value as 5%. Click on next. Then beware of the unit here. Period is second and the acceleration is meter per square second. So let's copy the results here. Beware of the unit, they are right. So copy it and paste the results. So we can have a look at the spectrum 1 diagram, which is accelerations versus period, and click finish. Then we have defined our first spectrum. Then the next step is to go to the gateway menu, cases and tasks, analyze tasks. We need to conduct the absolute sum, SRSS and CQC response analysis. So first off, the absolute sum. So populate the name on it, give the dynamic response, which should be the response spectrum. Click on next. So combination is absolute sum. Be aware that the model analyze task should be task 1. If you have conducted the other task, so you should select the model analyze 1. Okay. Then axis is go bold, and we only need it to vibrate in X direction, so we only select X. If the records specified to you or the requirement ask you to investigate the structure's behavior in Y directions, you should select Y instead of X. So click on next. You can start analyze. Then we still need to add the new analyze task, so we can just click new analyze task. So this one, there will be SRSS. Okay. Still the dynamic response spectrum. Click on next. Combination that first of all, the model analyze task will still be task 1. Combination is SRSS. We still only use X direction. Click next and finish. Then we add the last one, which is the CQC analyze. So that is still dynamic response spectrum. Click on next. Combination is CQC. Model analyze task is task 1, model analyze. So click on only select X, go to next, and finish. Okay, so let's have a look at the graphic. So at task, it says response in X, response in X/1, response in X/2. So in this case, that response in X in A3, that will be the absolute sum result. A4, there will be the SRSS result. A5, there will be the CQC results based on the sequence of here. Okay? So what we need to do right now is to select, for example, this is the absolute sum, and we can open the default image. it doesn't show. Okay, but we can open here the control setting, go to the nodal results, displacement, UX, control based on actual value, and have a look. So let's regenerate the image. So at this point there will be 17.26, at this point there will be 11.26 millimeters, so that you can get the mode shake here. Once again, if you are not sure about that, you can always click on select for animations and select these two, see the results. Then let's have a look at the next case, that will be the SRSS output. So here is 16.71, here is 10.36, as well as the last one, that will be the CQC output. Here is 16.71 and here is 10.37. So you can get the mode shapes of these three kind of calculations method by doing this one. Okay, so after you have watched this tutorial video and build your own very 2-degree of freedom system model, you should be able to understand how to build the 3-degree of freedom system models. So in general, you should first notice that if you need to specify more mass properties, so if you need, you can always go to properties, mass properties, and increase another mass here. And then go to the element, choose different mass, choose where they are attached to, where they are applied on, and alter their property. Then, since you have a 3-degree of freedom system, you should also have 3 beams. If the cross-section remains the same, so you can still use property 1. However, if the cross-section of some of the beams change, you may have to redefine a new cross-section property here. And then, add element, change the one that needs to be changed. It's important that you conduct the visual check by clicking on the section display, especially if the size of the columns, the cross-section size of the columns are different. Okay, that will be all for the GSA tutorial part of the section response spectrum analysis.